This video is on area polar region, and here I have a curve. The curve is r equal to 1 plus 2 cosine of theta, and then we have two loops, one inner loop and one outer loop. And here what we want to do is find the area between the inner and the outer loops. So the shaded area here. And so here's the graph of r equal to 2 plus 1 plus 2 cosine of theta. And we want to find the area between the outer loop and the inner loop. So we want this shaded region right here. And first, let's go ahead and find the points at the pole. And so to find the points at the pole, we can just set r equal to 1 plus 2 cosine of theta equal to 0, and then solve for theta. So we get, from here, we get cosine of theta is equal to negative 1/2. And then from trigonometry, we know that cosine of 2 pi over 3 is negative 1/2. Cosine of 4 pi over 3 is negative 1/2. Of 8 pi over 3 is negative 1/2, and then so on. And then now what we can do is graph the equation r equal to 1 plus 2 cosine of theta. Graph it from 2 pi over 3 to 4 pi over 3 and see what we get. And this is what the graph, this is what it looks like when we graph from 2 pi over 3, when theta runs from 2 pi over 3 to 4 pi over 3. So theta from 2 pi over 3 to 4 pi over 3. And then we can see that we get the inner loop. So what we want to do is find the area of the inner loop, and then find the area out here, and then subtract. And if we graph from theta from 4 pi over 3 to 8 pi over 3, this is what we get. We get the outer loop. And so, once again, what we can do is to find this shaded region right here, the yellow shaded region, we can find the area of this region here, and then find the area of the inner loop, and then we subtract. Once again, find the area of this, of the area inside the outer loop here, and then find the area of this, the area that's inside of this inner loop, and then subtract, and then we get this shaded region. So now let's find the area of this inner loop. And so it's going to be the integral 1/2 times the integral from 2 pi over 3 to 4 pi over 3. And then f of theta is 1 plus 2 cosine of theta squared, and then d theta. And then simplify, we get 1 plus 4 cosine of theta plus 4 cosine squared of theta. And then multiply everything by 1/2, we get 1/2 plus 2 cosine of theta, 2 cosine squared of theta. And then of course 1/2, the integral will be 1/2 theta, and then evaluate from 2 pi over 3 to 4 pi over 3, and then we get pi over 3. the integral of cosine of theta is sine of theta, and so we get 2 sine of theta, and then evaluate from 2 pi over 3 to 4 pi over 3, and we'll end up with negative 2 times the square root of 3. And then we need the integral for cosine squared of theta. Recall that cosine squared theta is the same as 1 plus cosine of 2 theta over 2. And then we can rewrite this as 1/2 plus 1/2 cosine of 2 theta. The integral of a half is just 1/2 theta. And then the integral for cosine of 2 theta is 1/2 sine of 2 theta. So here we get 1/2 theta, and then 1/4 sine of 2 theta. And then evaluate from 2 pi over 3 to 4 pi over 3. And we'll end up with pi over 3 plus the square root of 3 over 4. And therefore the area of the inner loop will be pi over 3 minus 2 times the square root of 3, and then plus 2 times this quantity right here, times. And so we end up with pi minus 3 times the square root of 3 over 2. And so this is the area of the region inside the inner loop. And then now let's find the area of the region inside the outer loop. And one more time, the outer loop here we generated by letting theta run from 4 pi over 3 to 8 pi over 3. And so the area that's inside the outer loop right here is going to be 1/2, and then f of theta squared is 1 plus 2 cosine of theta squared, and then we'll integrate from 4 pi over 3 to 8 pi over 3. And then just like before, just 1/2, 1 plus 2 cosine of theta is 1 plus 4 cosine theta, plus 4 times cosine squared of theta. And then we end up with the same thing, just like what we just got a few moments ago. The only difference is the upper and lower limits of integration. So here we'll go from 4 pi over 3 to 8 pi over 3. And then this part we'll get 2 pi over 3. And then for this part we'll get 2 times the square root of 3. And for this integral, then we'll get 4 pi over 3 minus the square root of 3 over 2. And so the area of the region inside the outer loop will be 2 pi over 3 plus 2 times the square root of 3 plus 4 pi over 3 minus the square root of 3 over 2. And then simplify, we'll get 2 pi plus 3 times the square root of 3 over 2. And so the shaded region here will be the outer area of the outer loop, area of the region inside the outer loop, minus area of the region inside the inner loop. So this is the area of the region inside the outer loop, and this is the area of the region inside the inner loop. And then we'll simplify, and then we'll get pi plus 3 times the square root of 3. And that's the area of the shaded region here. And that's the end of the video.